In the last video, the ESP01 was programmed as a transparent Wi-Fi UART bridge connected to an Arduino Nano circuit and controlled with the Roboremo Android app. In this video, the DT-06 Wi-Fi module with a transparent Wi-Fi UART bridge firmware will replace the ESP01 in the Arduino Nano circuit. The Roboremo interface will be updated to include low and high temperature set point adjustments. The DT-06 Wi-Fi module default firmware operates the real-time transparent transmission of data between serial and the Wi-Fi network. It is based on the ESP-M2 Wi-Fi module, but shaped like the HC05 and HC06 Bluetooth module with an indicator LED, switch 1 and switch 2 for firmware download. The power supply to GND and VCC should be between 4.5 to 6 volts. The UART serial, RXD and TXD pins operate at 3.3 volts but are compatible with 5 volts. EN is the chip enable pin, while state is the external connection for network status indication. See the datasheet for more details in the description below. The DT-06 VCC should be connected to an external 5V power supply instead of that of the Arduino Nano due to its power requirements. The GND of the module, that of the Nano, and the external 5V power supply should be connected together. The RXD pin connects to the TX pin of the Nano, while the TXD pin of the module connects to the RX pin of the Nano. The LM35 temperature sensor is connected to pin A0, and the input of the relay module is connected to pin D12. A heater is connected through the COM and NO contact of the relay to 110 or 220 volts AC. The DT-06 Wi-Fi module has an inbuilt HTTP server that can be accessed with a web browser for its configuration. When the module is initially powered up, it works as a Wi-Fi access point with a default SSID of Do It Wi-Fi and no password. When connected to the module Wi-Fi hotspot, open a browser and input 192.168.4.1 into the address bar to access the configuration window. The displayed status page provides such information as the module MAC address, station IP address if enabled, and the access point IP address. Click on the module menu and then Serial to display the default parameters of the serial interface, which we will maintain. Click on Module again and then Wi-Fi to configure the Wi-Fi settings. The module can remain as an access point or be set to station mode. It can also be set to operate as both access point and station. Under the soft AP settings, the access point can be disabled or enabled. The SSID, passwords, and IP address can be changed. Under the station settings, select Enable, input your home Wi-Fi SSID and password, then save. The module will automatically connect to your Wi-Fi router and its LED indicator will stop blinking. Check the status menu for the station IP address of the module and note it. To get the port number, go to Menu and select Networks. Note the port number for TCP server local port as 9000. Download the Roboremo app from Google Play Store. Insert a button by touching anywhere in the lower part of the screen and select the button. Position, adjust, and touch it to configure its parameters. Set its text parameter to heater on. T size to 25 and press to A. Insert another button and set its text parameter to heater off. T size to 25 and press to B. Touch the screen to insert a level indicator. Set its ID to temp. Its label to temperature equal #1 for the displaying of the temperature value. T size to 25. Min to 0. And max to 50. Touch the screen to insert a slider. Set its ID to S1. Its label to high temperature equal #1. T size to 25. Min to 0. And max to 50. Insert another slider. Set its parameters as the first, but its ID should be S2 and label low set points equal #1. Insert an LED. Set its ID to lead, label to LED, and color to red. Now touch the menu button and select Don't Edit UI. Building on the LDmicro program from the last video, the temperature sensor is read every 2 seconds and scaled to degrees Celsius. Here, the URAT data is received from the Roboremo app and stored in a shift register. The received data is checked to determine the required action. Hexadecimal 0A is carriage return from the app. A is to turn on the heater, while B is to turn it off. The expected data format from the Roboremo button is lead A /n. /n, which is also the carriage return, is stored in data 1 of the shift register, marking the end of data transmission, while the characters A or B is stored in data 2. The expected data format of the slider is S1-30 /n. S is the first data out, and it is stored in data 6 of the shift register, while 1 or 2 is stored in data 5. The unit of the expected set point is stored in data 2, and the tens is stored in data 3. They are converted from ASCII to binary format and combined into a single register. These values are then stored in the EEPROM. The transmission of the temperature sensor reading is limited to about once every second by this timer oscillator. Temp is the ID of the temperature indicator on the app. Here, feedback of the LED on-off status is sent, where lead is the ID of the LED on the app. 1 is to turn it on, while 0 is to turn it off. Finally, the relay connected to the Arduino Nano is turned on or off, either with the heater on-off button on the app, or by the high and low set point limits. Select the processor type of Atmel AV-Arrow 80MEGA328 32-pin packages. Set the PLC cycle time as 0.5 milliseconds. Ensure that the MCU crystal frequency is 16 MHz and that the URAT baud rate is 9600. Assign Y heater to pin D12 of the Nano and A temp to pin A0. Then compile the program and upload it to the Nano with AV-Arrow dudes. Ensure that the DT-06 TXD and RXD pins are disconnected before the upload and reconnected after the upload. Check the description for the AV-Arrow dudes tutorial video. To connect the app with the Wi-Fi module in access point mode, touch the menu button on the app. Touch Connect, Internet TCP, and then the plus button to impute the earlier noted IP address and port number, which is 192.168.4.1:9000. Then select the check button to go to the interface screen upon successful connection with the Wi-Fi module. Observe that the temperature level and value is being displayed. Touch the heater on and off buttons and observe that the relay connected to the Arduino Nano as well as the button on the app responds. Use the high and low set point sliders to set the set point limit for the heater. Thanks for watching. If you enjoyed this video, please click on the subscribe button, the like button, and the notification bell. Make sure to drop a comment below. See you soon.